So the other day while on board the aircraft, I was doing the paper chart amendments, and one of the charts that was replaced was the Atlantic orientation chart. Now, what we can do is have a look at one of the routes, and the route is called Upper Lima 211 Foxtrot. Now, that is the route that would be taken if you were flying from Ezeiza in Argentina to Cape Town, Africa. And this map is showing that route. There's South America. It goes across the South Atlantic to Cape Town, Africa. So what we're going to do is just have a look at the distances on this route and then look at some math for a globe and see if they agree. Now you can see very clearly on this map that a large portion of the route is tracking just south of 40 south latitude. There's position Kaken. It's south 40 degrees 10 minutes. It then tracks across to Ketis, which is south 40 degrees 14 minutes, and then it tracks across to Morsi, south 40 degrees 15 minutes, and across to Munes, which is south 40 degrees 20 minutes. So it's basically tracking parallel to and just south of 40 south latitude. Now let's have a look at some of the math that will confirm that these distances actually do match a spherical globe. And just to help visualize it properly, I've loaded up the route into ForeFlight, which is a professional flight planning app. There is the departure airport, the Upper Lima 211 route, and the destination airport FACT, which is Cape Town. So this is what it looks like on a globe. And remember, the best way to understand an aircraft route is to view it on a globe looking directly above. And as you can see, it's a relatively straight line because a great circle track is the shortest distance between any 2 points on the globe. And most air routes, international routes, will stick to as close as possible to a great circle track as they can. So first, some revision. 1 nautical mile equals 6,076 feet. 60 nautical miles along the equator equals 1 degree of longitude. There are 360 degrees in a circle, so 360 times 60 equals 21,600 nautical miles around the equator. That means from your starting position, if you travel 21,600 nautical miles directly east or directly west at the equator, you will return to your starting position. At any other latitude, the distance for 1 degree of longitude equals 60 times the cosine of the latitude. Now we're going to have a look at why that is so and why that confirms that flight plan distances do in fact match the geometry of a globe. So let's take a look at cosine. Cosine is the ratio of the adjacent side over the hypotenuse in a right triangle. A right triangle has two sides that are 90 degrees to each other. Now, if we consider this angle, then the hypotenuse is the longest side of the triangle. The adjacent side, logically, is adjacent to the angle, and the opposite side is opposite to the angle. So when we consider cosine, we are measuring the ratio of the length of the adjacent side to the hypotenuse. So we can now use this cosine to determine the distance around any given latitude on the Earth. If we consider the equator, 21,600 nautical miles, and the equator has a latitude of 0. Now if we go to the north until we reach the North Pole has a latitude of 90 degrees north. The South Pole has a latitude of 90 degrees south. So as we move north or south from the equator, we can use this cosine relationship because the radius of the Earth is now the hypotenuse on our right triangle. And this length here is the adjacent. So as the angle increases, the length of this adjacent side of the triangle is going to reduce. It's going to reduce by the cosine of the angle. You can see when that angle is 0, then the adjacent side is going to match the length of the hypotenuse. When this angle becomes 90, then the length of this adjacent side is actually 0. Let's have a look at that on an interactive demonstrator. So here we can see that relationship I was talking about, because we can adjust the angle, which is essentially going from the equator, 0 latitude, to the North Pole at 90 degrees north latitude. Now you can see for any given angle, the cosine value is provided here. Now if we go down to 0 degrees, the value is 1. If we go to 90 degrees, the value is 0. If we go to 60 degrees, the cosine of 60 is exactly 1/2, because you can see the length of line 0B is half of the radius of this circle. So now we can determine the distance around any given latitude. So now we can take a look at the formula for calculating the circumference of any parallel of latitude. We know the circumference of the equator is 21,600 nautical miles, and we know that this distance reduces by the cosine of the latitude. Now the circumference of a circle is 2 times pi times r. The equator distance is 21,600 nautical miles around the circumference. So the circumference of any other latitude is going to be 21,600 nautical miles times the cosine of the latitude. So let's have a look at some examples. So here are some examples for different latitudes, and it doesn't matter if you're looking at the north or the south latitude, because the values are the same. Latitude 30, north or south, the cosine of 30 equals 0.866. If we multiply that by the 21,600, it gives us a circumference of 18,706 nautical miles. And I'll show you how to do that. It's quite straightforward. We type in 30, we hit cosine, there's your 0.866. We multiply that by 21,600, and there's your 18,706 nautical miles. Now, just to show you that it does not matter if it is north or south of the equator, we can use minus 30 for a south latitude, hit the cosine, and it still gives us a positive 866. And the reason for that is because if we angle up 30 degrees, look at the length of this line, OB. If we angle down south latitude by 30 degrees, it's going to be the same distance. So it doesn't matter if the latitude is north or south, the circumference of the latitude is going to be the same. If we look at 45 south latitude or north latitude, the cosine of 45, 0.707, circumference 15,273 nautical miles. At latitude 60, again north or south, the cosine of 60 is 0.5, the circumference is therefore 10,800 nautical miles. Just to go through that again, 60 cosine times 21,600 equals 10,800 nautical miles. So how does this relate to our flight plan? So looking at the distance between two waypoints on that route, Upper Lima 211 Foxtrot, we have waypoint Ketis, which is at south 40 degrees 14 minutes latitude and west 03000 longitude. Waypoint Morsi is south 40 degrees 15 minutes latitude, west 02000 longitude. So we have exactly 10 degrees of longitude difference between the two waypoints. They are both just south of South 40 latitude. There's in fact only 1 nautical mile difference, so that's not enough to be significant in the calculation. At the equator, 10 degrees of longitude would equal 600 nautical miles. At South 40 latitude, 4015, that translates to a decimal value of 40.25. So we have latitude 40.25 degrees. The cosine of 40.25 is 0.763. So, if the Earth is a ball, the distance between Cetus and Morse should be 600 nautical miles times 0.763, which is the cosine of 40.25 degrees latitude, and that gives us a value of 458 nautical miles. Let's go through the math ourselves. So we have 40.25 degrees latitude. There's the cosine. Multiply that by 600. It gives us 457.9. We can round that up to 458 nautical miles. So let's take a look at what the actual distance is between these two waypoints. So here is the map again. Let's focus in on Cetus. You can see the location, South 40, 14, West 030. And you can see Morse, South 40, 15, West 020. And the distance is exactly 458 nautical miles, which is what we calculated ourselves using mathematics for a globe. So wake up, people. You live on a globe. Aircraft flight paths and routes all over the Earth can be tested this way, and they will always verify and match exactly to the globe. You can test it yourself. As you saw, the math is not that complicated. And this is an appropriate time to remind people that my friendly challenge to flat earthers to produce a simple flight plan on their flat earth model has gone unanswered for over 18 months. This was posted in December of 2016. The video has almost 50,000 views, and yet not one flat earther on the planet is capable of producing a simple flight plan. Are you really telling us, guys, that there is not a single flat earther in existence right across the entire Earth that knows how to navigate around the Earth? That's a huge fail. It's a huge red flag. Not one single flat earther knows how to navigate around the real world.